So this is question 3 from the 2018 January paper on Newtown Raphson, and it says identify an initial approximation to the only positive root of the function f of x equals 2 minus 2x minus e to the power of x using a graph or other appropriate method. Hence use the Newton-Raphson method to find this positive root of the function accurate to 3 places of decimal. Part 2, does f of x have any negative roots? Justify your answer. Okay, so we could do this graphically, but I'm going to just use a table function as a lot more students are using the table function. And I have the formula here that is given in the exam. Xn plus 1 equals xn minus f of xn over f dashed xn. Just remember that's a minus sign there, it's negative. Okay, so the first thing is to find the first approximation. To do this, I'm going to use a table function, so I will just use a calculator. All right, I'll go into table function, mode setup, table 3. Type the function 2 minus 2x minus e to the x into this, so it's going to be 2 minus 2 times alpha close bracket for x minus for e alpha power 10 to the power of alpha close bracket e to the x. Now it's positive roots only, right? So that means we're going to start when the x value is 0 and go up from there. So equals g, that's another function, just put it to 0 and ignore it from here. We're going to start at 0, grand, end at 5 is okay, and we will increase in steps of 0.5 for now. Okay, and that's it. So here we have the function, and what we're looking for is we're looking for a place where the function, the fx, right, is the height, right, the y value. This is our x value along the x coordinate. It's going to start at 0, 0.5, 1, 1.5, and so on up to 5. But already between x is 0 and x is 0.5, we have the function changes from positive to negative. That means there must be a root there because it has crossed the x-axis. The g of x we just ignore. Right, so if I was just to draw a little drawing of this, okay, of what we've got so far, roughly speaking, when x is 0, the function was up at 1, and when x was 0.5, it was down at minus 0.6, roughly minus 0.6. So that means that along here somewhere, this function is crossing the axis, and where it crosses the axis there, that is the root. Remember, the root is generally where the y value equals 0, or what's now called the f of x value equal to 0. Okay, and the root is between 0 and 0.5, and as a first estimate, I'm just going to let my first value x0 equal 0.2. I don't want it to be too close, just for the sake of showing you how to do this. Okay, so if x is 0.2, that means all these xn's here, these values are 0.2. The x here will be 0.2, the x here will be 0.2. But you see from the formula, I also have to differentiate it. So let's get f dashed xn, or just f dashed x first of all. Differentiate it. Differentiate 2, it becomes 0. Differentiate minus 2x, and I will have minus 2. And differentiate e to the x, and it stays as e to the x. There's a minus in front of it, minus e to the x. Okay, so our formula is that x1 is going to equal x0 minus then 2 minus 2 times x0 minus e to the power of x0 all divided by minus 2 minus e to the of x0. So that means now you can put this inside brackets if you feel safer, because that is a minus out there and it can affect the a change of signs. The fraction button is okay, it will accept that. Now, for our first value of x1, we are going to put in 0.2 for x0, so it's 0.2. This is our first estimate, okay? First estimate. 0.2 minus fraction button 2 minus 2 times 0.2 minus e to the power of 0.2 all over minus 2 minus e to the power of 0.2. Put this into the calculator and see what we get, and this is x1. So here's the calculator. I'm going to get out of this function, just get into ordinary maths 1, okay, and type this into the calculator. So I have minus 2 minus fraction button 2 minus 2 multiplied by 0.2 minus e to the power of 0.2, and then underneath the fraction I'm going to have minus 2 minus e to the power of 0.2. See what I get. Oops, that's not the power of 0.2. Delete that. E to the power of 0.2 equals, oh yeah, sorry, that shouldn't be a minus in front of that too. You have to go back. I was wondering about that. It's just not 0.2, not minus. Delete that. It should be 0.2. Sorry. No. That's just typical. Okay, so I get for my first value 0.3175 to 4 decimal places. Okay, so 0.3175. Now I'm going to put this into the calculator for x2. So x2 is going to be, instead of 0.2, now we're going to do 0.3175 minus 2 minus 2 times 0.3175 minus e to the 0.3175 all over minus 2 minus e to the 0.3175. So sort of lazy way that I'm going to do it is I've got the calculator sitting here. I'm just going to go back, and everywhere I've got a 0.2, I'm going to delete it and say 0.3175. There, delete that. 0.3175. Delete that. 3175. And then the very first one. Okay. Now all the x's are now 3175. And for my answer here, I get 0.3149 to 4 decimal places. That's fine. 0.3149. Okay, so now I'll scroll down a bit. And this is a repetitive thing, so now I'm going to do it again. X3 is going to be where we change the 0.3175 to 0.3149. So it's getting close there. I mean, if this was to 3 decimal places, it would be 0.318, and this to 3 decimal places would be 0.315. They're close, but not close enough. So now it's not 0.3149 minus 2 on 0.3149 minus e to the power of 0.3149. And this here part here is over minus 2 minus e to the 0.3149. Okay, that minus there is for the whole bracket. Now back to the calculator and do that lazy thing again, where I'll just change the 0.3175 to 0.3149. 49. Delete, 49. And this here is the last one. Delete, 49. And equals. There we go again. For x3, I get the same thing to 4 decimal places, 0.3149. So for the last two answers, for x2 and x3, I have them the same to 4 decimal places. We're only asked for the answer to 3 decimal places. So our estimate for the root, the positive root, is going to be of the function is approximately 0.315 to 3 decimal places. And that's that part of the question done. Now, the next part was, does f(x) have any negative roots? So the easy way of looking at this, or the quick way, is to draw a graph, and you'll see that it doesn't. So let's have a look. Or you can just look at the function, but I'll pan down a bit. So if we look at the function, some people don't like drawing the graphs. F of x is equal to 2 minus 2x minus e to the x. Now, that means we're being asked, is there a negative root? So then we'll let x become minus x to show that it's negative. So we'd have f of minus x is equal to 2 minus 2 times minus x minus e to the minus x. And if we tidy that up, that will become 2 plus 2x. Now that is positive. Minus 1 over e to the power of x. So as x gets more negative, this here gets bigger, and consequently, as x gets bigger, this here fraction gets smaller and smaller. It will eventually tend to 0. So it has very little effect on this. So as x gets bigger negatively, we're tending towards x plus 2x, and as this is always positive, because we've sorted out the minuses there, then f of x is not negative. There, when x is negative, f of x is always positive and greater than 0. Therefore, there is no negative root. No negative root, no negative. Alternatively, you could draw a graph for it, but I'll leave it at that. Thank you.